Let's first talk about why we need to study failure theories. Okay, here's a situation that we have discussed in class. Our parts turned out to be pretty complicated in geometry, and we may have different varieties of loading, and this part may work on a very complicated situation. So going through our mechanics analysis, we sort out a point. That point we call the most critical point. And at that point, we may have a three-dimensional stress states. We have sigma 1, sigma 2, and sigma 3 as the principal stresses. So to be specific, that our real situation, we have complicated part geometry, we have a complicated loading situation, and our operating conditions could be also complicated. And the environment could be, under low temperature, high temperature, and dust environment, many different things may happen. On the other hand, okay, so this is the real world situation. But on the material science world, and people have done a lot of standard tests. For example, tensile test, which is a very good example of standard tests. Basically, we have a bar, and we pull the bar or compress the bar, and so that the stress of each of this material element we can put out. Okay, then we can draw the stress state. So at each point, we can consider the materials under tension for this particular case. All right, we can figure out the stress. When failure happens, then we can define a particular strength. For example, for this tensile case, we can define yield strength, and if it's under tension, we can define the tensile ultimate strength. If it's under compression, we can define the compressive ultimate strength, so on and so forth. Okay, those numbers show, those symbols shows the sign we use for example, yield strength, we use SY. Okay, and ultimate strength, we use SU, but T means tensile. Okay, maybe for simple, we can use SU if the compressive and the tensile ultimate strength are the same. And similarly, SUC, C means compression. But this particular tensile test is quite ideal. Okay, basically, it is for a part of a particular shape. In this case, is bar shape. Okay, of the same diameter across the length, and the load is uniaxial, which means either tension or compression. And it is under a controlled environment. We're not talking about extreme situations or complicated operating conditions. So how to utilize this handbook data or material database to solve our design problems for such a complicated shape? So that's the question. Okay, and this question is what we want to answer by means of the failure theories. Okay, that's the end of this movie.